So last time we had a look at how you can put together a picture that has got lots of points in it that make parallel perpendicular lines, and all the points land on nice whole numbers. So if you haven't got your diagram together yet, I suggest you watch that video first. Once you've got a diagram together where you've got parallel and perpendicular lines and you've got some nice whole number points, you've labelled all your points and you put the coordinates of each of those named points. The next thing you need to do is to figure out the gradient and the intercept of each one of those lines and use the gradient and intercept to find the equation. So if we take the line ED for example, we choose one end of the line to be our x1, y1. So I've chosen the point E to be my x1, y1. We choose the other one to be x2, y2, so that's the point D. And then I just do the calculations. So on the top it's y2 minus y1, 1 take 5, the two y values subtracted, and on the bottom it's x2 minus x1, so 14 take 6. And that simplifies to negative 4 over 8, which is negative a half, exactly as we planned it in the last video, if you remember. The other thing that I need is the y-intercept. To figure out the y-intercept, I've got to kind of extend the line, or hold a ruler up against it, and see where it would have crossed the y-axis if we hadn't have stopped it before it got there. So as you can see, it looks like that line goes through the point 8. So my c value would be 8. And of course y equals mx plus c means that I can then take my gradient of negative a half, my c value of 8, put them into the y equals mx plus c and get the rule or the equation for that line ED. I can also of course check whether or not I got it correct, because if either of those points don't work in this equation, then I've made a mistake. So all I have to do is take my point E and my point D, put the x and y value into that rule in place of the x and y in the rule, and then it should make a true statement. If it doesn't, then I've stuffed up somewhere. Most likely mistake will be that you won't be able to accurately read what your C value is, and then you're going to have to use another method, but I'll show you that in a second. So let's first just check with one of the points. I'm going to check using the point E, that is the 0.65. I put 5 in place of y and 6 in place of x, and it turns out to be a true statement. If things are going wrong, the other way that you can find the equation is using this formula, your y minus y1 equals m times x minus x1. And by putting in your gradient and one of the 2 points, doesn't matter whether it's E or D, it'll come up with the equation as well. This is a more accurate method of doing it. So if reading off your C value isn't working out for you because either your graph isn't accurate enough or it's just a really tiny line and hard to read it accurately, then this will be a way that will guarantee you get the right equation. So this is the way that you'd show you working to find the gradient, and then of course you need to figure out what the C value is, and that will give you your equation that you can check to make sure that it is correct. Or you can use this method here on the screen as an alternative. Once you've found all of the gradients of the lines and all of the C values, then you can find all of the equations of the different lines. The last thing to do is to then write down the domain and range. Now don't forget, the domain are a list of all of the x values that the graph exists for, and the range is all of the y values that it exists for. I suggest that the way you go about doing this is draw up a table of values, and as you can see there, the x goes from 2 up to 6, and the y goes from 2 on the y scale up to 10 on the y scale. So our domain is going to be between 2 and 6 for x, and between 2 and 10 for y. But we need to write that down, and we need to write it down in the two different types of notation. So as I said, draw up a table of values, and on the first column you can have the name of the line you're talking about. So I've just done the first one as an example here with the line AB, and then I'm going to write down the domain. X is between 2 and 6, and I'm going to write it in the two types of notation. Don't forget that first one reads X is an element of, and then it's the set of values where X is greater than or equal to 2 or less than or equal to 6. And the interval notation for that is that I use a square bracket if it's a greater than or equal to, and I use a round bracket if it's just a greater than that value. And it's up to you whether you choose to have the endpoints, the lines, included or not. So that's domain dealt with. Range is the same sort of idea except for the y values. So y goes between 2 and 12. Then we would write 2 to the left, 12 to the right, and we've got our set notation up the top, and we've got our interval notation down the bottom. So that means we've now covered question 1 in part 3, getting the gradient, the y-intercept of each line, finding their equations, and we've had a look at question 3, which is the domains and ranges. In question 2, to state the equations of any lines which are parallel, we're just picking out the ones with the same gradient, and perpendicular lines, ones with negative inverse gradients. But it should be pretty obvious in your picture as well which ones are parallel and which ones are perpendicular. In question 4, we're asked to find the length of the line segments and the midpoints of the line segments. Those two things we covered in the part 2 video if you've forgotten how to do it, but here's a reminder of the two rules. And the third part, the equation of the line using y minus y1 equals m outside of x minus x1. I went through that one a bit earlier in the part 3 videos as well. So the last thing to worry about now is using your CAS or your Desmos to illustrate your picture. So all you're going to have to do is enter the equations that you found and use that conditional line to include their domains, not the ranges, just the domains. Again, the video to that in part 2 goes through an explanation of that. So hopefully that's going to be enough for you to finish off this task. If you get stuck on any bit or you want me to help you out, don't forget, come in to meet. I'm there every lesson waiting for people to come and ask me questions.